Welcome back, everybody. Welcome back to the channel. So today we're going to pick off pretty much where we left off in the last episode, where we're going to talk about expressions. But before that, since I kind of mentioned it in our last episode, I'm pretty much almost done with the compiler at this point. Still got plenty of work to do, but I'm getting pretty close. So that ended up basically having me fix a bunch of bugs because I've been doing tons of testing and things like that. So before we get into what we're going to talk about today, let's just kind of see what are some of the things that I have added since the last time I kind of mentioned bug fixes and updates. So if you guys are following the series, these are going to be the couple things that you're going to need to do to make sure that your programming language is going to behave in the same way as if you're following the series completely. And by the way, some of these, not all of these, but some of these bug fixes are absolutely required, and you will probably have some pretty nasty bugs if you don't fix them. So keep that in mind. So some of the couple things that I've added here, you can kind of see this right here. I added more override operator symbols for allowing the user to override things. So I removed and or, so that's no longer here. I removed that for logistical reasons in terms of how I compile things. It just would not have been a very good thing to have as support for an override operator. So I removed and or. I would highly recommend you do this. And then finally, I added, the left brace here, or basically allowing you to pretty much take the place of a class for accessing it as an array. So I think I actually have an example. So if I go to syntax, yeah, so here's a perfect example. I was just testing this before I filmed this video. And basically what it allows you to do is, this is really cool. It basically allows you to have a class and you have this operator of left and right brace, and you can effectively put whatever you want in here. So most override operators typically, like if you have like a plus plus operator, depending on whether or not you have like, the number here or not will depend on where the placement is. So there's like a post and a pre plus plus operator. But the cool thing about this one, why I think you should add it, it allows you to put anything in here. So like I can say, this class has this override operator. I can say string, right? Str string, and I can literally return whatever the heck I want. And I can pass literally a string in here and say some data. And that's going to call this function. It does whatever it does, and it returns whatever it wants to return. So that's something really cool. So definitely I would recommend you add that as well. That's going to be really powerful, and it's also going to be related to a feature that we're going to be adding later on called dictionaries. So that's another reason. All right, so let's look at here. Hold on, I'm actually going to go back up here and remove these so that way I don't sweep over them again. All right, so there's another bug fix that I did. That is in ParseReferencePointer. We've gone over this before. There's been several issues with this function that I've kind of been fixing kind of as we go along in the YouTube series. So there's another bug where, like, let's say you had, I don't know, like, you guys know, like, I support generic classes of, like, class of K, which holds a generic type of T, and I could say K of var, whatever, right? The problem with that is if you try to create this class, what I was doing before was I was always assuming if you have like some identifier and then a less than symbol, that it has to mean that it must be a generic class, which is not always the case because you could have, for instance, some variable, let's say num1, for example, right? Let's say we had num1 and we wanted to see num1 was less than 100. Well, what if this k class, even though it is a generic class, and in fact it doesn't even have to be a generic, what if this k class overrided the operator less than and you wanted to call that operator? Or what if this was just a var and you did that? Like, it doesn't always, less than symbol doesn't always equate to it being a generic type. So I added some logic to make sure that that's the case. So in your parse reference pointer, you just want to add this to both up here. So we had like two spots where we checked for generics. It's in this while loop in here, so you want to add the exact same code. I'm not going to go over it in two spots, but it's basically the same thing. So you want to, here, let me remove this. If the next token is a less than symbol, then you want to get the current token. That way you can reset it later. You want to expect the less than symbol, enter protected mode, and try to parse a U-type list, which is basically just going to be a bunch of U-types. Then we check to see if the next token is equal to this symbol. Now, if it isn't, the assumption is that maybe this isn't like a generic class, right? Obviously, if it's not a generic class and it's also not like the user saying, something less than something, obviously there's going to be a bug. Maybe the user made a mistake, so they'll get an error regardless. But from our standpoint, we just want to make sure that we don't like screw up the user by processing a less than symbol incorrectly. So you want to check to see if the next token is equal to that, and then you want to fail, of course, because in case there was something going on with parse view type list, which is entirely possible, then you want to expect that character. Otherwise, you want to ignore any errors generated by this, reset the current token to the old value before we processed everything. And of course, you want to free up the last sub AST. So you want to free up this AST here. That's very important. And then you also want to free up the last token that was generated as a result of this. And that token would be this here because we expect that value. And you do need to absolutely have this value added to the AST because we're going to be using this token, this less than token, on the compiler side to figure out when to parse a generic class. So that's why we need that. And I just created this function. All it does is just accesses the tokens list and just pops back the value or whatever the last value was off of the list. So that's all that does. Hopefully that makes sense. Now let's see what are some other things. Okay, so here's another thing I added, override operators. So when we're processing an override operator, in order to support this, the way that it's done on the back end is a little bit different than what the user will see. So if we expect an override operator, we advance, of course, you guys know what this code does. If what we find is an override operator, you can see here that it starts with this left brace, which is totally fine. So we check to see if the AST is not equal to null. Here, let me remove this. And so we check to see if the current token is equal to a left brace. If so, then we want to add the left brace, and then we want to expect the right brace, but we don't want to add it. There's a reason for that. We'll see why that is on the back end side of our compiler, but it's also just unnecessary. I mean, if you see that you have the left brace, you obviously know it's related to an array operator overload, so you don't really need both of them. That's kind of unnecessary. But yeah, so don't add that. Otherwise, if the current override operator token is not equal to a left brace, then we just add it like normal and we return true. So this is going to allow us to basically do that. Otherwise, the user would do something like that, which just looks weird. So you want to allow the user to do that. So that way it's pretty clear what operator they are overriding. So there was that fix. Let's see, is there another one? Okay, so here's another one. Let me remove this one. So when it comes to getting branches, now we see this code plastered everywhere. It's the same code that's plastered at the top of every single function, which basically just generates a new branch in the abstract syntax tree list. And the reason why I wanted to add this was because if you guys, so like if we go up to AST expression, there was an issue with this. Whenever we process an expression, if you guys remember, whenever we call this function, we're always looking at it from the standpoint of peak at 1, which basically means whenever we're processing an expression, like let's say we're processing this expression, we're always processing it from this point of view, from the character before the expression even gets processed. So whenever we went to create a branch, we would basically save or store the line and column that their branch was on and relative to the token before the actual AST or the actual expression was processed. So what that would do is that would give you some very weird prints in terms of what happens. So like for instance, if I did like this, right? If I just entered here and I got an error with this expression, it would show me this and it would point to this symbol here, which makes absolutely no sense. And they wouldn't actually see that this was the actual code that was processed or that actually broke. So what I basically did was I checked to see if the current type that we're passing in for get branch is of type AST expression. If so, then I get the next tokens line and column. Otherwise, I just do it as normal, get the current tokens line and the current tokens column. And that was pretty much it for that bug fix. This one's very important because it allows the user to get appropriate and correct error reporting, so that way we know everything is happening. So let's see if there's anything else to do. All right, so it doesn't look like there's anything else. So now let's actually go to parse expression. Parse expression. And I think where we left off was we last did self, was it, or new? It was new expressions. Okay. So next we're going to talk about, and we already did lambda expressions. We're going to talk about size of. This one is a pretty easy one. Basically, this one, the concept of size of is it's kind of like Java's dot length. It's my own kind of version of it. So let's say we have like a var array of prime numbers. So let's say we have, this prime numbers array, and let's say we have size of primes. We can assign that to size of prime numbers, and that basically just, this doesn't return the size in memory, so this isn't going to return like 15 bytes or something. I showed this to somebody and that's what they thought it was. This is actually going to return the physical size. So if we say like equals new var array of 100, then it's going to return 100 as the size of this object, not how many bytes in memory it's taking up. We will have a way to figure out how many bytes in memory each object takes up at a later date, but that's not what that does. So size of is a pretty easy expression, so we might be able to actually get through a couple of other expressions today. So let's see kind of what happens. So first, what you want to do is create a branch called size of. Now this is an absolute expression, so we can just immediately create the branch and we don't need any protections for like entering protected mode or anything. So we create the branch of size of expression, we expect size of, and then we basically expect the left paren, we parse an expression, and then the right paren. And the assumption is that the expression is going to be something that we can check the size of. So like you can't get the size of like 900 or 9,000 or whatever, right? That doesn't make any sense. So we're going to have to evaluate that on the compiler side, but that's totally fine. And then we have our after expression code here. So if it's not equal to as, then we reset the branch to the size of expression. And we basically, for size of, I mean, it's a number. So technically we can increment and decrement. I think this is such a bad idea, but I'm just going to let the user do it. It's going to be unlikely that they're going to do it, but we will support it. So if there's a increment or decrement after size of, then we just go to check increment, which is below here. We'll get to increment and decrement in a little bit, but we go there. Otherwise, we don't support anything else. So we don't support dots. We don't support left braces. We do support as. So maybe we wanted to convert this value into like I don't know, an integer or something. Then we can do that. But otherwise, if there's a dot, we complain about it. If there's a left brace, we complain about it because it's not an array and you can't access it through a dot. So otherwise, after that, you return true. And yeah, that's pretty much it for size of. So let's see about left paren. So what this is this is basically like a paren expression. So this is the equivalent of if you have an expression like surrounded by parentheses. So if you surround any expression by parentheses, that's pretty much what that does. So this is an absolute expression, so we can just immediately create the branch here. We don't need any protections. So we say we create a branch of AST paren expression. We advance one token. We add the left paren. I don't even think we need that. I don't know why I'm doing that, but whatever, it's fine. We add the left paren. We parse our expression that is going to be encapsulated inside of the parens, and we we expect our closing paren, and we just reset the branch. Now this is bad. So here, I'm going to actually do this. So of course, I'm going to, yeah, so if we have an as this will protect us, so that way we can have both left and right expressions. And yeah, for paren, we support everything, right? Because technically you don't really know what is inside of parentheses. It could be a class, it could be like a number or something. So you want to support everything. So you want to support increment, decrement, dots. You want to support left brace. Maybe it's an array inside of here. You also want to support as, of course. So you just want to add, you can copy down this code here. You just add the respective go-tos for each individual situation. After that, and of course you want to return true too as well because, like I said, it's an absolute expression, so you just immediately return true. After that, we have another one. We're actually going pretty quick, so let's see if we can maybe get to left brace here. I think this is array expressions, yeah. So after that, we have our null expression. So with null expression, I mean, you guys know what that is. I don't even think I have to go over this. If you've ever programmed in Java, it's just assigning an object to null or nothing, basically. So we check to see if the next token is null. We expect that value. We encapsulate that value into an expression, and we do not allow anything. As you notice, I don't have as here. I don't think it makes sense to cast a null value to something else. So I'm just going to ignore as and just return. Pretty much. I'm not even going to entertain the fact that that could even be a value. I'm not even going to complain about it. So if we have a increment or decrement, of course you can't do anything with the null value. It's nothing. Same thing for dot and same thing for left brace. So just add the respective errors here, and that's how you do null expressions. After that, we have our array expression. So if we ever wrote down a array expression, so like here, for example, for left paren, we have one of our go-to labels here. So it's called array expression, and we just peek one character to see if the next token is equal to a left brace. And if so, then we process this. So we'll just go over this, and then next episode we'll probably close out. So we have literally two other expressions that we can process, and that's pretty much it for primary expression. So that's pretty exciting. So we have our left brace. If the next token is equal to that, this is another absolute expression. So we just create our array expression. We expect the left brace, parse our expression. This is going to be considered to be the index expression, right? Because if you have an array, the assumption is that if you're trying to access an array at a certain index, it has to be it has to evaluate to a number. So this is going to be expected to be evaluating to a number or a var in our case. Expect our closing brace, and then we check to see if there's like a dot or something. So if there's something after, which is totally fine, right? Because what if you have like an array of a class? Then you want to access that class and get a field out of there or something. That's totally fine. So we check to see if the next token is equal to a dot, and if so, then we want to enter protected mode, and because just in case if maybe something went wrong, we can backtrack. So we enter protected mode. Whoops, keep doing that. We save the old token, and then we try to parse a dot notation call expression. And if that doesn't work, then we basically free up our last sub in our array branch. So we want to keep this array because obviously it processed correctly, but maybe there's something wrong with this dot. Maybe the user just put a dot by accident or something. Totally fine. So if we did not parse a dot notation call expression successfully, then we free up the last sub that was created as a result of this function. We ignore the errors and we reset the current token to its old value. Otherwise, if it was successful, then we have these after expressions, which, again, this is another case. I think we ran into this when we parsed dot notation call expressions above. I don't think these are necessary because dot notation call expression already kind of handles these things, but I'm just going to leave it I'm just going to leave it. And, if it happens, it happens. If it doesn't, it's totally fine. It's not going to hurt anything. So if we successfully parsed a dot notation call expression, we want to fail just in case any errors happened. We want to check the next token to see if it's an as, and I did this again. We want to set the branch to the last sub AST if the next token is not equal to as. And you guys know what this is. I don't have to explain anymore. So we support increment, decrement, dot, left brace, and as. And we add our respective go-tos. After that, we return true regardless, because I mean, even if this fails, like even if they put an accidental dot or something, then I mean, it doesn't negate the fact that we successfully did process a array expression. So we want to return true there. Otherwise, like let's say the next token after our array expression was not a dot. Let's say maybe it was another array. Then we want to basically just say unexpected symbol. and then we put the left brace as the unexpected symbol. The language, like I said before, does not support arrays. That's a complex topic, and this is the second time that I've written a compiler ever. So from scratch, at least. I've been building on my compiler for several years, but it's not an easy thing to put in, and I think I've put enough stuff in for it to be a good enough series. So we will hopefully get to array support later on in 3.0, but we'll see about that. After that, we check to see if the next token is equal to an increment or decrement. I'm just gonna do this. That's some old code that I had a while ago. So just do this, right? So if you have your left brace and like we basically check for all these things, if the next token, so if it's not a dot after we process our array expression, if it's not a left brace, check to see if the next token is the increment or decrement, then just jump there. Otherwise, just return true if we end up getting down here, because there's entirely possible that we just parse an array expression and nothing happens. Like there's none of these things that it will end up going into the if statements. Then we just return from there. And yeah, so that's pretty much it. You know what? I'm actually, you know what? I'm not even gonna like, let's just finish this off in this video since I'm already kind of going through everything. So let's just finish off parsing primary expressions as a whole. So next, after that, you want to parse a as expression. Oh crap, I guess I have to show you guys how all these things look. That's totally fine. Since I can process statements now, this is going to be very easy. So let's see how we do casting expressions in increment and decrement. So here's our as expression. Again, remember to update all of your go-tos, respective go-to statements. If the next token is equal to an as, then here's where we see why we didn't do the, or why we did not reset the branch if it was equal to as, because we need both expressions to be there. So in order to do that, we need to basically encapsulate the current branch. Like let's say, for example, I don't know, I'll pick an example here. Let's say, let's find something that supports as. Okay, so we have this. So what is this? This is a base, right? Is that a base? No, that's a dot notation call expression. Okay, let's go to a base. That's even better. So let's say we want to have the base class, and we want to cast that to some other class. So as you know, the current branch would have a sub AST called AST branch expression. So when we go down here to encapsulate it, we would basically be encapsulating a branch expression into a primary expression and then into another expression and then into a cast expression. And then once we have the cast expression, then we want to get that sub AST, and then we want to basically just add the next respective data to that AST. So that effectively umbrellas those two expressions that we were processing before, or that one expression we were processing before, inside of this cast expression. It's a bit of a weird way to do it, but that's kind of the only way to do it, at least based on how my code's written. So we basically expect the next token to be as, and then we parse a utype. And I mean, that's pretty much it, because as basically represents like, here's your expression and here's the type that you want to cast the expression to. So that's kind of why it looks like that. And then after that, we want to fail the errors. That is an interesting, I think that is a bug. Okay, so I'm going to remove that, never mind that. So after you parse as, then you want to check for other things. Now I don't support, like, you can't do like as and then, cast it to something else and then cast it to, some other value. That doesn't really make any sense syntactically. So I basically don't allow anything after as. So if you're going to cast something and you want something to be after this, like let's say the int class actually supports plus plus and minus minus as operator overloads because it represents a number. You can't say like at null, or like, here, I'll actually give a better example. So let's say we have a prime number of a class int, and let's say we cast prime number to an int. You can't do this because that doesn't, I mean, that just looks nasty syntactically. So you theoretically or technically you'd have to put this in parentheses and then plus plus it. And as you know, we go up here to left paren. In our paren expression, we support increment and decrement immediately after the paren expression. So that works perfectly fine. So there's that, and we basically just error out everything. So we don't want to support anything after as, so just complain about it. You already know, we've already seen this in multiple other spots, so I don't think I have to go over it. You can just kind of pause the video and copy down all of the various errors, or just copy paste it from a higher expression that we already parsed, because it's pretty much the same stuff. And finally, we have our plus plus and minus minus. So this is our check increment go-to statement or go-to label. So again, be sure to add or update all of those spots. And in there, this is basically expected. So there's two types of plus plus and minus minus. I'm gonna go here and do this. So this plus plus and minus minus basically represents the what's called a post increment expression. So there's two types. So there's a post, which means after, and then there's a pre, which means before. So pre, we already went over that a while ago when we were talking about parsing expressions before we got into parsing a primary expression. But post is something new, which basically means in programming, you want to get the value of this prime number first, and then you want to update the variable after you get the value. So we'll see how that gets processed later. But yeah, so that's the concept behind that. So you want to create a post increment expression. Then you want to advance a token. You want to add the token. That's very important. You definitely need to do that because we need to know which one it is, because we're just saying it's a post increment expression. After you add the token, then you basically do everything else. So with plus plus and minus minus, it's a bit of a different situation. Again, remembering we're writing a compiler, so we have to think about everything. So not only like there's certain situations where like the user can plus plus prime number. What if they want to plus plus it again? Now I know this doesn't really make any sense. I know this isn't realistic, but theoretically the user can do this. So what this will do, like let's say we initialize prime number to 1. Um, then if we plus plus it, well, it's going to be equal to 2. And if we plus plus it again, now it's equal to 3. So that's what this expression will generate. It'll just return 3, or actually it'll return 1, and then it'll just set prime number to 3. That's pretty much what it'll do. But let's say, I don't know, prime number, like here's a perfect example, right? This prime number integer is not a native var. So this integer class has a function that overrides this operator plus plus, and it calls a function. As you know, with override operators, you can return whatever the heck you want. So, I mean, this function can return anything, and maybe it returns a class or whatever. So you just want to allow the user to infinitely call plus plus or minus minus as many times as they want. Also, you want to support dot because maybe the plus plus operator overload returns some class that you want to access. So you want to say dot some field, or maybe you have, and this is going to be the way how it works for every operator overload, not just plus plus. So it just depends, but um, you have dot, you want to support left brace because maybe it returns an array, right? So what if you have an operator overload that returns some array, and you want to access that array and do whatever you want to do there. Otherwise, what if you have, as, so, this plus plus operator overload returns a class, represent it as some other class. So you can do that as well. And of course, all of the same logic for like if we have an array, want to access it at index of 1. We can also do dot some field because we have all of that logic in parsing an array. So everything kind of connects together. We finally have that link where everything is kind of working in a circle. That's kind of what you want. You don't want a compiler that has dead ends where eventually if you write a wacky enough expression, it'll either crash the compiler or you just can't do anything. So you want to give the user infinite possibilities of expressions to be able to generate. Now I know that makes it hard on you, but I mean, that's part of building a compiler. So after that, you want to return true because that's pretty much we've successfully processed a increment or decrement, and this is assuming that we didn't have anything after it, and we just return true here. Otherwise, you just return false, because obviously, if we went through all of this and we couldn't figure out what the heck it was, then obviously the user either did something wrong, or maybe we need to be a little smarter and maybe try a different type of expression. So we got other expressions to process after this. This isn't everything, but this covers the vast majority of all the things the user is going to experience. So I'm going to skip the video and I will be back once I have an example so we can kind of go over all of these that we went over today as quickly as possible. All right, so I'm back. That actually took me like freaking 30 minutes to figure out how to do this. Anyway, so let's see how all of these statements are compiled together. So if we look at the first one, so we have block, as I said before, I can process statements now. So immediately after we start, or immediately after we finish processing expressions, and I show you guys how to parse everything, then we can go straight into how to parse statements. But for now, we can just kind of see high level what they look like. All of this code is defined in what's called an init statement. We'll get to what that is later. So the first thing we went over was a SizeOf expression. So let's see how that looks. So we have our expression, and of course it's represented as a statement. So we have our expression, our primary expression, our SizeOf expression. So it's a token of SizeOf. You don't even need these characters, so that's completely unnecessary, but that's fine. So we have our, here, see if I can move that up a little bit more. So we have our expression, which represents the thing that we want to get the size of. We have a primary expression of a dot notation, call expression of a U type of some array. So that looks to be good. Next, let's look at our, what is this? A parent expression, yeah. So we have our parent expression with some extra stuff in here. So we also have a post increment expression. So we see we have our parent expression, a primary expression, or no, actually, this is just a AST expression of a primary expression of a parent expression, and we have our expression here with a primary expression of a dot notation call E. Now there's a bunch of so I know there's like an expression here and a primary expression here, but you guys remember this is just another expression encapsulated within inside of here, so that's why there's like multiple of the same types of ASTs. Then we can see here we have our primary expression of a dot notation call expression of num. So that looks to be good. We have all of our things segmented properly. And of course, as you know, we slap this stuff typically on the end of the AST after we process it. So we just have our post increment expression slapped after our dot notation call expression, which is exactly what we want. Makes processing things on the back end a lot easier. So let's look at the next one. So the next one we have is our null expression. So that one's going to be fairly quick. It's just an expression. It's a primary expression of a null expression. It just has the words in there. To be honest, I don't even think you need the word null. I actually don't. Yeah, no, you don't need the word on the back end. So you can remove that if you want, which is totally fine. After that, we have our array expression. So we have a statement, expression, primary expression, dot notation call expression. Now this is going to be an after expression, so we want to process, remember, this part first, this part next. So that's how it works. So we have our dot notation call expression of array, which looks to be good. So that's this part here. And then we have our array expression. Yeah, so this is going to be the second part. And so we have these tokens here. I don't think you need those. Yeah, you can just get rid of those. Any tokens that we actually need on the back end, you'll quickly see it. It's pretty obvious. Some things I require, but majority of the ASTs that I'm processing, you don't need to know what tokens were in what AST. It really doesn't matter. You're just taking up memory. So if you want to be efficient with your compiler, you can leave out all of the things that we don't need. So you have your expression, primary expression, literal of 1, which looks to be good. and that represents the index expression of our array expression. So that's what that is. Finally, we have our as expression. So we've already seen plus plus, so I don't have to, that's why I didn't put it after this. But we have our casting expression here, where we have a statement, expression, primary expression, cast expression, um, and we have a as, and then we have two ASTs. So again, this is why I was saying you need you need to not update the branch and the parse expression function, which is over here, yeah, in the parser, because we need two ASTs to be inside of this one. So we have as our first AST our expression, which we need to cast, which is a primary expression, dot notation call expression of number, or num for short, which looks to be good. And then inside of this cast expression AST, if we scroll down, we can see, okay, so it's right here. So we have our second AST, and if we follow the line, we can see that's in the same AST as this one. So we have our AST utype of a type identifier of a reference pointer event. So this is our utype that we need to cast. So everything looks to be good. And that's going to be it for today, guys. So we got a lot done. We went over a lot of various different things. So that's really good. So once we start working on the actual backend side of this compiler, things are going to pick up pretty quickly. And once we start to get close to, or right before we actually start working on the backend, I'm actually going to publish a video pretty much going over what to expect with this YouTube series, because I want to be transparent with you guys. I want to let pretty much everything that we're going to be learning from this YouTube series, and now that I kind of have an understanding of what, like, everything that the compiler already supports, since I'm pretty much done with it, I can kind of give you a good picture of what you can look forward to over the next couple of months or so, as I'm kind of showing you guys all the code. So I wanted to mention that I think it's very important. If you think this, once I kind of go down the list of all the things that I'm going to show you, if you think it's a bit too advanced, definitely write them in the comment section below. I can point you to the right direction to kind of get you up to speed in terms of maybe things you might need to learn. Just keep that in mind. Like I said, I'll make that video a little bit later, and we'll kind of go into what we can expect from the YouTube series. So, as per usual, if you guys would love to help out the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you get there, watch, start, and fork the repository. That's going to give this repository a lot more visibility and let other developers know that this language exists. Also, if you're kind of interested in maybe seeing some of the things that I do on a daily basis, you can check out the remastered branch. Pretty much anything other than master or remastered is not used, so just keep that in mind. And when you guys get over there, you can check out the commits. I usually put some pretty wordy commits, and lately I've been pushing some pretty humongous ones. So you can kind of get the gist of what I've been doing in each of those commits without really having to jump into the code base. Also, if you're interested in maybe seeing some of the things that I'm looking to add to the future to the language, or maybe stuff that I've added in the past, you can check out the docs folder. And in there's going to be two main files. There's going to be the change list file, which is going to pretty much contain everything that I've already done to the language thus far in terms of like updates, bug fixes, so on and so forth. And then you can check out the roadmap file. That's going to be pretty much everything that I've either done to the language and or am looking to add into the future. And I update this one pretty regularly. It seems like I'm updating it on a weekly basis now, which is kind of interesting. I'd highly recommend you check this file out. It's very interesting, gives you a ton of insight into the language, so on and so forth. So that's going to be it for today, guys. Of course, if you're new to the channel, definitely subscribe and hit that like button if you guys love what I do and want to continue to learn more about building a programming language. But as always, until next time, I'll see you guys later.